Good morning. It's straight up 10 o'clock, and I'd like to welcome everybody to the 2020 Virtual Dairy Discussions Program. My name is Fred Hall, and I'm the Iowa State University Extension Dairy Field Specialist in Northwest Iowa. Today's 2-hour program on manure system is in partnership with EcoEngineers. My co-host for today is Lindsay Nielsen, Marketing Coordinator with EcoEngineers. Lindsay, welcome to the program. A little housekeeping before we start. We hope you have some questions generated by the discussion. If you would type those into the Q&A box, they will be addressed at the end of the presentation. And finally, at the conclusion of the program, there's a short questionnaire. We would ask you to click on that. It's there in the chat box, and help us out by filling that out. You'll note that there are several other links in the Q&A or just above the chat box there. Those are the PDFs for the slides being presented, as well as some other white sheets that are related to what you will be hearing today. Without further ado, I'll go ahead and introduce our first presenter. She is Shelly Peterson from the State Energy Office at the Iowa Economic Development Authority. She will discuss how IEDA can support Iowa dairies as they consider changing manure systems.
All right.
Shelly,
good morning. Thanks, Fred, and thanks for the invitation. I am with the Iowa Economic Development Authority, and we're located here in Des Moines, and happy to be here to talk more about a topic we've been working on for some time. So the State Energy Office is housed at IEDA, and we offer a mix of programming, funding, and activities to spark energy and economic development. We've got a staff of 7, and we're sponsored with funding from the Federal Department of Energy, along with some support from a group called the Iowa Energy Center, which works through our office. Some of the things we've done more recently are an energy plan, followed up by a series of special reports on topics that are of the most interest here in the state. One of which was a biomass conversion plan that we wrote a couple years ago, and really got us started looking at the opportunities for biogas, especially in this agricultural sector. Some examples of some work we've done lately that might be of interest are energy storage projects, and several of these are listed, but this is just a good example of how energy production and land use is becoming much more tied together in this state. And I really see biogas kind of following this same pathway as we go more to distributed energy and making these resources more available throughout the state. Another example of that is a mobile energy storage system that we've recently worked with several partners on. And this project really deals with resilience and the importance of being able to provide energy in emergency situations and have a wide variety of dependable and available energy supplies. So kind of along those veins, we do believe renewable natural gas can offer many of these same opportunities in the state. We've got just widespread biomass resources. This can be manure, corn stover, cover crops, landfills themselves actually can produce methane. And then there's a lot of food waste from the many food processors in the state, and then both from the consumer level as well. And all this has value in a renewable natural gas system. These types of projects can offer a lot of benefits to the state as well. Not only can you generate revenue from that energy resource, but we're really beginning to explore the water quality benefits, odor control benefits, the ability to reduce the burdens on our landfills, and really begin to look at the soil health as part of this overall system. The photo shown in this slide is from one of Iowa's probably first successful biogas systems in the state. And this is operated by Brian Sievers in Stockton. And he's got 2,400 head of dairy cattle and has been running this system for going on 7 or 8 years. And just a lot of lessons learned that he's shared, and I think really helps prepare this next generation of digesters in the state. Another example of a biogas project is Verbio has repurposed the DuPont cellulosic ethanol facility built in Nevada to begin accepting corn stover and producing renewable natural gas in the coming year. And in addition, they're also going to produce corn ethanol here. So it will be the first facility in the US to produce both ethanol and RNG, and just another example of how this technology can fit with the many ag resources in the state of Iowa. So this is a heat map graphic that I think really illustrates the potential for this industry in the state. We're the #1 pork producing state. We've got 1/3 of the hogs in the country are coming from all of Iowa's counties. We rank 12th in dairy production as a state with over 1,300 dairy herds. And so when you combine these two sectors, you can really get to an economy of scale to justify a lot of projects, especially through this northern counties in our state. As I mentioned, our office has been working in this space for a couple years. We've done a lot of mapping, like the graphic shown here, trying to identify where are the animal confinement operations, where are the natural gas pipelines, looking at the synergy between ethanol plants, which can use a lot of natural gas, and these animal confinement operations. And so we've looked at these various feedstocks, different end users, done some economic analyses, and again, just are moving ahead with thinking that these projects could really open up in the state and really serve as an economic driver. We've issued some grants to Iowa State University. There's a lot of research going on anaerobic digestion. And in early 2021, we've got a anaerobic digester project development guide that EcoEngineers is working on, which should be released, and hope to just maybe provide a roadmap for people that are looking to get into this type of project development. I found this interesting data that I got from the Innovation Center for the US Dairy, and they have established some environmental stewardship goals, and I think anaerobic digestion fits really well in this space. So they're looking to drive this industry to become more carbon neutral, optimize water use, and improve water quality. And I think anaerobic digestion can really play a space to move along the goals of the dairy industry in your efforts to be responsible agricultural partners. And it's not just the producers that have goals along these lines. A lot of the food processors throughout the state and throughout the country are also really bringing forth pretty ambitious sustainability goals. And so there's, I think, a definite partnership between the producers, the food processors, with these common goals. I think really set us on a good pathway to bringing biogas systems into the state. Also wanted to mention, you know, a number of you might have seen anaerobic digesters at municipal wastewater treatment facilities. This has been a treatment technology for decades. It works well in this sector. And we're also working with this sector to further this type of technology because I think it'll just really further strengthen the supply chain as more and more projects, whether they're in the public sector or the on-farm sector, get built in the state. So in response to the COVID pandemic, the governor assembled an advisory board recently, and there were a number of committees and subcommittees that met. And one of these was the Agricultural Working Group. And this group came out with a number of recommendations, 2 of which kind of floated to the top. And that was a need for long-term water quality funding. But more importantly to this discussion is the formation of a carbon sequestration task force to really look at the role between farmers and long-term sustainability efforts. And so this group is going to kick off in 2021, and I think will really help us evaluate anaerobic digestion and other actions that can really support these larger carbon goals that the state will be considering, and how we can play a space in the national effort and programs to better account for carbon management, especially as it relates to soil health in our state. And so again, I'm with the Iowa Economic Development Authority. Our sister agency is the Iowa Finance Authority. And just yesterday, I learned more about a project for 3 large anaerobic digesters that's been proposed in the northwest corner of the state. And a request came into the Iowa Finance Authority to help them with a bonding project. So the Iowa Finance Authority has the ability to bond for private activity bonds, and was looking to partner with the group to do that. So we'll be watching that too as the next months come forward to see what role our organizations can play as partners look to find ways to finance these types of projects. And that was all I had to share today.
I'm Kris Kohl. I'm an agricultural engineer with Iowa State University Extension Service, and I have been working with livestock producers up here for the last 32 years. I'm going to talk a little bit about successful manure systems that we use for dairies. Dairy manure slurry, as it comes out of the cow, kind of has the problem that it's too thick to pump very effectively, yet it's too thin to scoop. So it gives us some unique problems. We also produce a lot of it. With our cows, we're going to be pushing the water through them. And normally we're going to figure about 12 to 20 gallons per cow per day. The nutrient content is also relatively speaking low in comparison to either beef cattle or swine. It's made up normally about 10% or so solids. At 20%, you can scoop it up and put it into the a spreader, and it will spread just fine. It's mostly water, and water is heavy, and at this point we don't see it as all that valuable on our landscape. Dairy manure tends to have a high cost for handling, storing, and land applying. Generally speaking, if we look at all of those things, the fertilizer value in the manure will not cover all of the cost. And then it often, I'll just say, contains what I'm going to call hidden hazards. Sand bedding is a fairly standard thing in our free stalls. The sand is going to be very corrosive and wear hard on steel moving parts. Oftentimes there'll be other stuff that can end up inside the manure that's, I'll say, junk, like twine. I was at a dairy, and they were having a lot of problems getting rid of their manure, and they couldn't get people to even pay for the nutrient content when it was land applied at free. I went out to the storage pond, and I looked across the whole thing, and it was covered with jellyfish. And I'm like, what is all this jellyfish? I've never seen jellyfish on a manure storage structure. Got over, got a stick, pulled a few of them out, and they were all AI gloves and straws from them breeding the cows. They'd get done doing that. They'd take the AI glove off and the straw off and throw it into the manure handling system. It all ended up out in the pit, and nobody wants their field to be covered with little sheets of plastic. Not only does it destroy the manure handling equipment, but it also creates a real problem with planters and harvesting equipment. And I could see real quickly that the problem with nobody wanting the manure was all of the junk that was put into the manure. So we need to keep the manure clean in order for it to have things. We also have safety issues with manure, and especially in Northwest Iowa. We have high hydrogen sulfide wells. We're also using a lot of distillers grains that have high sulfur content, and that has led to much higher sulfur content in our manure. And as that degrades, you get hydrogen sulfide gas. You add water to it with condensation, and that's sulfuric acid, which is battery acid. And I think if you've ever spilled battery acid on you, you know how corrosive it is, and around the batteries, how it destroys steel. It also is a hazard in that it's heavier than air. And if you get high levels of it and you breathe in it, One breath will kill you. At lower levels, you'll get headaches and end up with some health hazards. Also, of course, falling into it, it's like quicksand. Can't really swim in it, and you're going to pull you down quickly. And kind of last on that list is it's a dirty job, and it's also one that needs to be done very timely when the weather conditions are right to get onto the field, but it ends up being last on the list for getting done often, and so we're pushed at the very end. This year's been a great year for getting it out with a dry early fall. Normally we're pushing to the very end, and trying to get it land applied is right at pushing the snow cover. Got this picture of a pit, and I don't know how many times on a, we can talk about safety. They do have a safety rail there. I don't know how many times it's been hit, but it's probably getting close to the last hit. And if you fall in there, especially with your equipment, and I've had other pictures of equipment in pits. I didn't choose to show them today, but it's never fun to end up there. We're going to pump it. We probably need to add just a little bit of water, maybe from the milk house. Wash water will make it so that it pumps a little better. Little runoff from an open lot area. And if we're going to pump it, we probably need to separate out the sand so it doesn't destroy the pump. And adding a little bit of water does make it a little less valuable, though not that terribly much. Pumping the effluent, then we're going to use liquid handling systems. Wastewater runoff. Look at a few of the different pumps that are there that can handle it. Submersibles. Head and pressure when we're going to pump it. Manure, dairy manure is very viscous, so it has higher head losses than other types, but we need to make sure that the pump is adequate for getting that. We'll take a look here at an example of a tank that's maybe 15 feet above the tank. So we've got 15 feet of or so of that head. We have the resistance in the pipe and the fittings, and fittings oftentimes add an awful lot to the amount that we have lost. Pressure head is also can be measured in PSI, but we'll start with this one. So we have a 10-foot pit. We have then 90 feet of concrete storage through a 1/2-inch line at 20 PSI, an angle, elevation, and a elbow, and you're going to end up with a loss of about 13.3 feet of head, and that's equivalent to about 6 PSI loss. Flow rates, pumps are often rated using clear water, not effluent, and they're going to perform at a lower standard than they would. Solids content, slurry, 4 to 10% solids, and it coming out of the different facilities, we're going to have issues. Probably in most of these, we want to end up with a clean manure and get rid of any of the sand or other heavy things that go through there. Maintenance on pumps. Do they have greasable bearings? Most of them are sealed bearings. Is there screens to keep the big chunk out that can't be pumped? Are there breakable service parts? And how easy are they to service? They're always in bad locations. Brass, cast iron are resistant to corrosion and often a good choice. Generally speaking, they're going to be setting in the liquid, so they don't have to be primed by hand, which is another problem. Centrifugal pumps are pretty good, low pressure, low head pumps. They can handle the levels of solids that we have. They should have impellers that have enough clearance so that there is room for a little bit of material in there, and it reduces the amount of wear as well as the plugs and blockages that you have. However, these things do not do well with things like net wrap and those plastic AI gloves. They seem to end up on the middle shaft and wind up long enough until they have broke things. Diaphragm pumps can handle a little bit more debris. They're also low head pumps. They have a low cost of operating, but they don't have enough pressure to ever go out to an irrigation system. The last set of pumps we have is piston pumps. They're high pressure, high head, but low flow rate. They can transfer high solids content, and they can handle probably the most foreign material in them. Axial flow or helical gear. These also can move a lot. They're not going to be super high pressure unless you keep adding bowls. However, you can do that. They tend to have real problems with abrasive materials. So keys to pumping it: know what you are pumping, get the right pump for the job, and make sure that you can service it and get the parts that you need for it. Another part that I just wanted to talk about a little bit, when you are pumping water for irrigation, and since over 80% of the manure is water, we normally are looking at a cost between 1.5 and 5 cents per 1,000 gallons pumped. Normal cost for pumping manure, if you're going to be hiring it done, is somewhere in that at least $0.015 per gallon rate, which is very high in comparison to applying manure. To make it a solid manure, you can add bedding. If you do separate, and we have various separation equipments that are out there, from like a fan separator or so forth, they will separate solids from liquids in dairy manure. You end up with two piles, and I'll say the question is, are they more valuable than the one you started with? Is one more valuable, one less valuable? They also require two separate sets of equipment for hauling. Talk just about a little bit about that. Now I'm showing a horizontal beater spreader. pretty much the industry is all moved to vertical beater spreaders, and they have, I'll just say, a pattern that is 10 times better than the horizontal spreaders I'm showing here. And look at availability, especially if you're going to be selling it. What is the first year availability, following years? Dairy manure, beef manure, we're going to be assuming about 30 to 40% of the nitrogen is available first year. Potassium and phosphorus is all 100% available. This is a sample of some solid manure that we're looking at, and this is out of the standard tables that DNR uses. Nitrogen at 18 pounds per ton, phosphorus at 12, and potassium at 11. At about today's value for nitrogen, phosphorus, and potassium, we have a value of about $21.50 a ton. Now, if we look at nutrient replacement value that we need for growing corn, for silage, we'd be looking at about 170 pounds of nitrogen need. 25 tons per acre would give us 150. On the phosphorus and potassium side, we end up with much more than we actually need. Not all landowners are willing to pay for excess nutrients beyond the next year's need. You need to work with them, and as we get higher and higher concentrations of livestock in northwest Iowa, and it continues to grow, the counties are more favorable to livestock in the northwest corner of the state, but we are going to end up with times when it's going to become harder and harder to get that applied. I would encourage everybody that is looking at that to try to compare your cost against the what the elevator would actually be, not only the material but also the land application cost, and maybe to take a look at, if you're knifing it in, a value of a tillage pass or so that's also in that. You're still going to end up oftentimes with application costs that are going to exceed the nutrient content, especially with the liquid. Absolutely, you need to test the manure before each application, especially if your storage pit is outside. A drought year like we just went through, the nutrient content goes up greatly. When we have the very wet years, it tends to go down. And I would test it, I'll say 2 weeks before you're ready to apply it. You can probe that pit, get the nutrient content, and then you can make the appropriate application to apply what's needed. As far as testing the soils, if you have soils that are low in P and K, however, if there's a very long history of putting manure on those particular soils, generally speaking, the P and K are going to be high, and they will tend to get higher. As we put on nutrients onto our fields, it is also very important that we get them uniformly put on every square foot of the field. We don't want to end up with a situation like this where the manure has been applied and around where it's been applied has been missed. All of those misses are going to be at great reductions in yield. Where it's too high, we have the potential for leaching that out, going into the groundwater. That's why with the solid manure applications, calibrating it using the vertical beater spreaders has greatly improved that, so that we can end up with good application patterns that are covering everything that's out there and not missing spots. With our satellites, with yield monitoring, you can find those application errors in the field so easily. And if it's your responsibility, there's probably somebody that wants to hold you accountable. So in summary, dairy manure is a slurry, so it's one of the more difficult to handle. It, generally speaking, has low nutrient content compared to its weight and volume. If it's going to have value, we have to keep it clean, keep the junk out, so that our equipment can work properly. And you can't haul water on wheels very far and keep it cost effective and be safe. And with that, I will turn things back.
All right, so next will be Brad Pleima. He's a senior engineer for EcoEngineers. He's also in charge of our asset development consulting team and our RNG line of business.
Some good information, hoping here to really build on that and talk about what is the opportunity for some of these dairy farms. And just to get started, I did want to show just a quick video about EcoEngineers. It comes a lot better from me, or from this British guy with a nice deep voice than it does from me. So I'm going to play just a quick video a little bit about EcoEngineers.
Carbon is the biggest disruptor of the 21st century, and the world as we know it is changing. EcoEngineers can guide you to make the best decisions as you navigate toward your clean energy goals. Our diverse team of carbon analysts, engineers, scientists, auditors, and regulatory specialists are trusted advisors of the clean energy fuel sectors worldwide. Clean energy regulations are a maze. We simplify them with an unbiased approach and fully manage your compliance. Modeling your carbon reduction is complicated. We quantify your emissions with a rigor based in science. Together, we can create markets that will protect and grow your investment. We create sustainable solutions for a better tomorrow. We are EcoEngineers.
All right, well, that was exciting. We haven't done that before, so we're just trying some new things out here. And now we'll go talking about the dairy opportunity in front of Iowa dairy farmers, but also any really dairy farms across the United States. And what are there's a lot of development, a lot of RNG work happening at dairy farms. I think here at EcoEngineers, we're tracking somewhere around 200 dairy to RNG projects. Currently, there's about 15 or 16 of those that are in operations, that are taking advantage of the incentive programs that we're going to talk about, that are operating now, and many, many more in development. And so we'll talk about what that looks like, and then we'll round out the discussion with a case study, and how can Iowa farmers take advantage of this opportunity, and really what are the next steps and what needs to be done here. So what is, just to recap here, what is biogas? And it's really the methane that is generated from anaerobic digestion, and it can be from a variety of different feedstocks. In this case, we're going to talk about dairy manure. And the goal of anaerobic digestion is really to extract the remaining energy that is in that dairy manure and convert that to biogas. And then that biogas can be beneficially reused under a wide range of options. You can generate power, you can generate heat. We're going to focus more on generating renewable natural gas, which is essentially taking out the impurities of biogas, CO2, the H2S that Kris talked about, the water vapor, removing that and making as pure of a methane product that can be a replacement and a substitute for fossil natural gas, just the natural gas we burn in our houses and for heat. This RNG, renewable natural gas, can be a direct replacement of that product. And it's done from renewable sources. And because it is taking, converting energy from a waste product, from manure, there are incentive programs that really want to reward projects. And we'll talk about why dairy projects have some of the highest value incentives in the entire world, and how farmers can take advantage of that. So what are some of the evolution? What's biogas been used for historically? What's not included here is just flaring that gas, not using it. If you go by a landfill or a digester and you see that giant candlestick flare, that's really just combusting the gas that's being generated and not beneficially reusing it at all. In fact, there's a cost to doing that. But throughout the last couple of decades, the people realized they could use that biogas for other beneficial uses. Primarily, that's been burning that as boiler fuel and replacing that natural gas. We've also seen a lot of power generation, and CNG vehicle fueling and pipeline injection have been the next wave of this opportunity for biogas, and that's what we're going to spend most of our time talking about here, because that is the highest value. Currently, the highest value use is cleaning up the gas, injecting it into a pipeline, and using that fuel that you produced as a vehicle fuel. One of the primary incentive programs that is available to any project across the United States, if you're using it as transportation fuel, is the Renewable Fuel Standard. And many of you are probably familiar with the RFS. It's really been taken off with ethanol and biomass-based diesel. But renewable natural gas, when you use the biogas, convert it to RNG, that can generate RINs under the RFS program, just like these liquid fuels can. The program was passed in 2007 and really started to develop in 2009, 2010, again, focusing mostly on ethanol. But in 2014, the EPA opened up the ability for renewable natural gas to qualify for an advanced cellulosic RIN, D3 RIN. And those D3 RINs have the highest value of any of the RIN categories. And it really spurred a lot of development, not just in dairy RNG projects, but at landfill gas, or for landfill gas, at the wastewater treatment plants that Shelly talked about. And we're still seeing a lot of development happening at those types of projects. The goal of the program is to reduce the greenhouse gas emissions from transportation fuel. And the Congress, when this law was passed, Congress initially wanted to replace 36 billion gallons of our transportation fuel supply by 2022. That's 20% of all of the fuel that we consume in this country to be from renewable sources. We're not going to hit that level, but we are climbing, and we're about a little over 20 billion gallons towards that goal. And that current schedule is set out to 2022, but the RFS will continue beyond that. So the program does not go away here in a couple of years. It will continue in some form beyond that. So how do you take advantage? How would you generate these RINs from renewable natural gas? And RNG is very different from liquid fuels like ethanol and biodiesel. So in those liquid fuels, you actually have to generate the ethanol, blend it with gasoline in the transportation fuel, and then dispense that as vehicle fuel. When we all go to the pumps, we see that Iowa ethanol sticker on a lot of the pumps, and by blending the ethanol into the gasoline supply, the producer or the dispenser can generate RINs and generate these credits by doing so. In renewable natural gas, it's very different, because the physical molecules, while they are completely fungible, they're a replacement for natural gas. The physical molecules do not have to be dispensed as a fuel, and so we'll talk about why it's very, very important of the pipeline injection component. So our pipeline natural gas grid is all connected through interstate pipelines, and we have a handful of major natural gas sources. When we clean up the biogas, we make RNG and we inject that into the national gas pipeline system. That system is treated as a big storage or a sink, and you can inject that gas here in Iowa, and you could have a virtual contract to use an equivalent volume of natural gas, knowing that natural gas is coming from the same pipeline system. You can have an equivalent amount in a contract to dispense that gas, say in San Diego. So the San Diego bus system could say, I'm going to partner up with this Iowa dairy farmer. The dairy farmer may produce and inject a certain volume of gas into the pipeline on a daily basis. The San Diego bus system dispenses an equivalent volume of that as transportation fuel, as CNG vehicles or LNG vehicles. And doing that really completes this loop and completes this life cycle. And for natural gas, that is an approved and a standard way to demonstrate that your fuel that you produced at the digester is being used as a transportation fuel, even though we know the physical molecules produced aren't making its way to California. And so that's why in this graph we show we have a physical pathway where the biogas is injected into the pipeline. It goes into the commercial distribution system, and it just goes down the pipe and is probably consumed, as building heat, as process energy, the physical molecules. But those environmental attributes, the renewable components of natural gas, that's this virtual contract. So we can use the grid, this dashed line, to tie up and match up this CNG LNG end user in California, in New York, in Maine, in Iowa, wherever that may be. We'll talk about another incentive program that a lot of this dairy RNG is going to the California markets because there's an extra incentive program to do that. And that program is called the California Low Carbon Fuel Standard, or LCFS for short. And what that program goal is very similar to the RFS, except it's targeted specifically to California transportation fuel emissions. So the goal of that program is a 20% greenhouse gas emissions reduction from transportation fuels within the state of California by 2030. It incentivizes the development of these low carbon fuels, and it's very different. It's a complement to the RFS program, but it's very different in how it's administered. And so under the RFS, it's a volume-based system. So if you produce a gallon equivalent of fuel, you get a credit. In the California program, it's targeted towards, it's performance-based, and the better lower and lower emissions and the emissions reduction that you get from your specific project, the more revenue and the more credits you will generate from that same volume of fuel. So it's very different than the RFS, but in the same concept, where you have to demonstrate that the fuel that you produce is used as a vehicle fuel. And you may say, we're here in Iowa talking about Iowa dairies. Why are we talking about the state of California and the LCFS program? And it's that concept of displacement that I mentioned before that really opens up the California market to Iowa producers. So we have a lot of ethanol plants here in Iowa. Many of those ethanol plants are taking advantage of the California LCFS program by railing, shipping their ethanol into the state of California to take advantage of this program. With renewable natural gas, that pipeline injection component opens up that virtual contract, that displacement. And so now you don't need to physically ship this fuel to California to take advantage of this program. And it's big. It's a big benefit to these types of projects. And we'll show some economics here towards the end of what that looks like. The benefit of the Lcfs is it's a statewide program. So you can generate Lcfs credits through the California program and credit RINs through the RFS program. So it's a stackable credit. And so it enhances the incentives to doing these projects. There are some other programs, state specific. Oregon has a clean fuels program that is currently implemented and ramping up. There's many other states. British Columbia and Canada also has a program, but the state of Washington, Colorado, New York, Massachusetts, and even some Midwestern states are investigating what would a more localized Lcfs program look like for their region and for their state. So right now, these projects that are being developed, many of them want to use this as transportation fuel in California because the Lcfs program has a high value right now, and it's also that double dipping of credits. You get both the federal credit and the California state credit. So we'll talk about why that's important moving forward. So I touched on this. Happy to answer any questions about this. Won't get too deep, but in the state of California, every project is analyzed differently. So if we had two Iowa dairies next door to each other, they may generate a different volume or different amount of revenue, a different amount of credits from these two programs, from the Lcfs program, because every program is assessed individually. So how is the feedstock collected? All of the things that Kris talked about manure management, all of that has to be assessed and modeled in order to understand what that facility's carbon intensity score is. So you'll hear the term CI, which is carbon intensity of the fuel, which basically is a model and a measurement of the emissions reductions from your specific facility. And that is used then to monetize the value of this RNG into the Lcfs program. So what we looked at here, this program is detailed out already to 2030. We know what that looks like. The RFS program is more of a year-over-year review. The California Lcfs program has this detailed schedule to 2030. So there's more clarity and there's more definition around what the future goals of the program are under the California program. And that's important, as we'll show some examples here in a little bit later. The California Lcfs program is not a RNG focused. It's really fuel neutral. Any fuel, any project that can reduce the emissions, reduce that carbon intensity of gasoline or diesel, of petroleum-based gasoline or diesel, can take part in this program. And you can see all of the various projects these are current operating projects that have pathways into this California Lcfs program. So you can see we're focused on bio-CNG, bio-LNG. That would be using this RNG that's produced at an Iowa dairy farm as a transportation fuel in California, but it also looks at electricity usage, biodiesel, renewable diesel, ethanol, and hydrogen, renewable gasoline. So it's a very broad program, and RNG is a one portion of the overall program. So just to summarize what this process is, and to reiterate why an Iowa dairy farm could participate in the California program and the federal RFS, is that physical and contractual pathway I mentioned earlier. So if you look there at the left, we have the production facility, in this case, an anaerobic digester at a farm. We have the project owner, somebody that is upgrading that biogas to pipeline quality renewable natural gas and injecting that into the natural gas grid. We know the physical molecules will be commingled with everything else that's in all the other molecules that are in the natural gas pipeline. And then that gas is burned as a user. It's extracted and used along that system. And then again, that contractual pathway then for those environmental attributes are done in California or other states, but mostly focused on California for these dairy digester projects. So I touched on the carbon intensity, and why that's important is because the carbon intensity at a specific site, at a dairy farm, that is a driver of how many credits and how much revenue is available for these projects. So that's something that needs to be modeled and analyzed at every specific farm. And farms that generate RNG more efficiently than a neighboring farm will be rewarded under the California program, and with more credits and a better or lower carbon intensity score. And again, that measures in all of the life cycle components. So how did you get the manure, the pumping that Kris talked about? How did you get that into the digester? How efficiently did you convert that manure into biogas? How efficiently did you convert the biogas into RNG and use that as a transportation fuel? So what type of manure matters, and under the California program, this is specifically right now set up for dairy and hog manure, dairy manure and swine manure only. Beef cattle is excluded under the program, although there's some efforts to get that included into the program. Turkey or chicken litter also does not qualify for this ultra low score, which makes these projects very, very attractive. Those still may be good projects, but the value into California is significantly more for dairy and swine projects. So what we need to do is, what's happening at these dairy farms and these swine farms is oftentimes at the dairy farm, the manure is going into a lagoon for a longer period of time, and the solids are settling towards the bottom. There's anaerobic digestion happening at the bottom levels of that lagoon, and methane is being generated and bubbling up through the levels of the lagoon and being emitted directly into the atmosphere. So the California program is basically rewarding projects by stopping that. So we all know methane is much more potent and impactful to the environment than carbon CO2. And so when you stop the emitting of that methane from a dairy lagoon or from a deep pit at a swine farm, you get the equivalent value under the California program. And that's what makes these projects very, very attractive. So when we're doing the quantification of this and that modeling, we have to look at how much manure goes into the lagoon, how often are those lagoons cleaned out, because we're trying to model and estimate using the Lcfs regulations how much methane is being emitted from that farm, and that will directly correlate to how much credit and how much value that a project would get from ceasing that. And now not only ceasing that emissions, but now taking that energy in the manure and extracting that. The nutrients can be still applied to the field, just like Kris said. We're extracting that energy and using it as a fuel. So we're producing that renewable natural gas as a vehicle fuel, and these incentives are there to do that. So what does that look like from an RNG standpoint? These numbers here are just general carbon intensity scores, and the unit is grams of CO2 equivalent per megajoule. Basically, it's a measurement of how much emissions you're reducing. And if we look at that, if somebody is just dispensing fossil natural gas from the grid and using that as a vehicle fuel, that typically has a carbon intensity score of around 79 or 80. And so when you see these projects, we're reducing the emissions from that fuel significantly. By landfills, almost by 50%. Same thing with wastewater plants. But if you look at the dairy and swine manure projects, it has a negative carbon intensity score. And so what that says is these projects are actually removing carbon from the atmosphere and are carbon negative, which a lot of people and there's a lot of programs that are willing to pay an incentive for that. And that incentive is shown here on the right, where we show what the value of dairy manure is. And this is in a decatherm or in an MMBTU of RNG produced. The value of that gas right now is somewhere around $2, has been upwards of $3 over the last year or two. So the physical commodity, the molecules that you're producing, has a value of $3. But if we start looking at the value of RINs and the value of the Lcfs credits, you can see significant added value because of the renewable attributes of this. So right now that RIN number is a little bit low right now. It's somewhere around $15 per MMBTU. And the value of the California credit is significant, $65 per MMBTU in an assumed negative, highly negative carbon intensity score. So you can see you're producing at these dairy farms, you're producing molecules that are worth $3, but the RFS and the Lcfs programs are rewarding this emissions reduction, and almost all of the value is derived from these two programs here. And this is the reason why all of these projects across the country are happening, is to capitalize on these incentives and because of this carbon negative score here. So just a quick case study. So what would this look like at an actual dairy farm here in Iowa? What do these systems look like? I know Shelly showed a picture here, but here's a general anaerobic digestion system. It's oftentimes a big tank. These can be above ground. These can be built into the ground with a cover. But what you're doing here in this photo is the manure is going into these tanks and holding there for a certain period of time, oftentimes around 30 days. And that the biogas is being generated, the methane is being generated, and it's being captured under those domes. And then that biogas then is piped, compressed and piped to a biogas upgrading system, which is shown on the right, that removes all of the impurities, that H2S and the CO2 that we talked about before. And this equipment here will produce that pipeline quality RNG, and then you inject that into the natural gas grid. In Iowa, that's oftentimes Mid-American Energy, Alliant Energy, Black Hills Energy. All three of those utilities are active in projects in Iowa, and all three of those have experience with these types of projects. In a couple of the operating facilities here in Iowa, Mid-American Energy and Black Hills Energy both have projects in Iowa that are doing this exact same process, that are injecting RNG into the pipeline. A couple at landfills and a couple at wastewater treatment plants here in Iowa. So what is the opportunity for dairy farmers here? What happens? Typically, you're diverting that manure from lagoons or the current manure management plans into these new anaerobic digesters. Those are generating biogas. You're upgrading that gas to RNG and injecting that into the pipeline. And then you're selling an equivalent volume of that gas into California, hopefully, because that's where the large amount of incentive lies. And you're also generating RINs. And so what happens, you generate these credits, and under the RFS and under the Lcfs program, both of those programs require obligated parties to purchase those credits. Because if you refine or you import petroleum-based fuels into California, then you have to comply with the Lcfs. If you're an oil refiner anywhere into the U.S. and you sell petroleum-based fuels as transportation fuel, you're obligated under the RFS in order to meet the compliance obligations of the program, and usually that is done by purchasing RINs and Lcfs credits from projects like this. So then you use those extra revenues to pay off the project and supplement dairy farm income. Oftentimes this works best when you have the larger the better, because the more gas, the more revenue, the more economies of scale you get with the equipment, with the digester, and with that pipeline injection. What we found at EcoEngineers is somewhere around that 2,000 head on the dairy side works best. That's not to say a smaller project couldn't work if you have a pipeline nearby and the conditions are there, but just a general rule of thumb is somewhere in that neighborhood oftentimes makes for a project that will have a payback period of less than 5 years. And that's really what kind of the, it's not a firm rule, but the threshold of what people are looking for in when they're investing in these types of projects. Oftentimes these third-party developer or entities that are investing in low carbon projects will come in and partner with the dairy farmer. So in all of the discussion that we've talked about, the dairy farmer may not have to do any of this. They could work with a developer and a third-party entity to come in and build all of this, pay for it, and then share some of the revenues back with the farmer. Or we've certainly seen some of those farmers take this on themselves and capture and take all of the revenue that's available to the project. So what do you have to do? What are the next steps in order to look at this? Usually it's assessing the feasibility. What's your herd size? Do you have a pipeline that's close? What are the technology options at the size of a farm that you may have? Then we want to look at the overall economics. How much does that cost to build? How much does it cost to operate? And what are the potential revenues from a project, an RNG project, and compare all those. Take a look at what some of the deal structure options may be and talk those through with the farmer. Do you want to take something like this on yourself? Do you want to work with a developer? Or do you want some kind of middle ground where there's a shared ownership in a project? You can start talking with those developers, and ultimately, if everything makes sense, if all of these boxes are checked, then you can start actually developing a project. And just to give you a little bit of a feel, obviously every project is a little different, but what we looked at here is if we had a dairy farm that had 3,000 milking cow equivalents and was using a lagoon-based treatment before this digester, this project would come in and build the digester and build that upgrading equipment and inject it into the pipeline. A project of that size could displace upwards of 400,000 diesel gallons every year. So essentially what's happening here is you're becoming a mini refinery from manure, taking that manure, extracting the energy and converting that to a fuel that can be used and combusted in an engine. I mentioned before the carbon negative aspect of the project. These not only economically make a lot of sense, but just from a environmental standpoint, to cease that methane emissions from a lagoon, it's a really good story to tell at the farm level of now not only are you not emitting that methane at the farm, but you're creating and you're offsetting diesel with a renewable carbon negative product. Typically at a project of this size, in that 3,000 head size, somewhere between 10 and 12 million to do all of that. That would be kind of a total project cost. The annual operating costs be somewhere around $750,000 to $1 million per year, and the revenues from, in this example, would be somewhere around $4 million from those RINs and the gas sale and the Lcfs credits. And when you take out O&M and you kind of pay some of the people to help you get this fuel to California and line up those virtual contracts we talked about, you'd have somewhere in the neighborhood of $2.5 million annually on your earnings before income taxes, depreciation, and amortization. And depending on how that's set up, depending on who's taking this capital risk and who may be operating the facility, then this 2.5 million is then divided up between the farmer and the developer, and that can be 100% to the farmer if they are the ones that are doing this whole project. It could be 75 to 90% to the developer if they're the ones that are doing that. I think either way, the farmer is getting a share of this additional revenue, really for selling the manure and letting a third party come in and use that manure and extract the energy for this transportation fuel. So that's just a quick summary of what we've seen projects happening. Obviously that these projects can work at a smaller level. The bigger the farm, the better, and these costs can scale somewhat accordingly. So with that, that's all I had here. I'm going to turn it back over to Fred and Lindsay. I know we have several questions.
Thanks, Brad and Kris and Shelly. We do have a couple questions. Fred, we got you on here?
I believe so. Can you hear me?
Yes, we can.
Very good.
I can just get started here. So there's a lot of questions about small farms, and here's one that's just really, maybe Kris could help with this too, is how many 2,000 head dairies actually are there in Iowa to be able to do this? And if you don't have that many milking cow equivalents, what do you do? What can you do?
Can I kind of jump in?
Yeah.
In Sioux County, our average dairy size is about 550 cows. We range from over 8,000. I believe recently we've had a change, but smallest herd is about 90 cows. So we do have a lot of groups where they're close, where 2,000 would be available, as well as several dairies in Northwest Iowa that hit that 1,600 to 2,000 range.
And I think, Fred, just to build on that, is a trend that we've seen in this is to group up projects, like you said. And so if you can find, if you can put together 4 or 5 farms that are in the same general area, it's possible to analyze and aggregate those head in order to, and then to make a viable project.
Mm-hmm. And I guess we call that model the hub and spoke approach. And you can also start to combine swine manure with dairy manure at that point as well. And it can be profitable to, run several miles of new pipeline to interconnect these farms within a general vicinity as well.
Yeah, a lot of options there, Shelly. You could almost have a community type digester where if you could get manure into a centralized facility, or you could have a small digester at each farm and then pipe the biogas in low pressure pipeline in order to one common upgrading system and one injection point. We've seen all of those be analyzed, and many of those are underway right now.
So there's some questions about the digestate. Are the nutrients in the digestate monetized? And
I don't know if I should take this, but as far as the N, P, and K nutrients that are going to be what we use for fertilizer on the field, the digestion is going to be basically working on the carbon and the organic matter and a conversion there. It really will not have any effect on nutrients coming in and out, other than changes in moisture would change the concentration.
And I know there is some work coming out of Iowa State on that topic. It's my understanding that those nutrients are more tightly bound to the soil when that manure is land applied, and actually will help retain those nutrients in place where they're needed, as opposed to running off.
Upgrading biogas, here's a question, starts off with a statement. Upgrading biogas to RNG is very costly. Are there local uses for the actual biogas? And what are the opportunities for the biogas before the RNG for small farmers?
Yeah, it's a really good question. That the cost of upgrading has come down as more and more of these systems have been rolled out. The size requirement has been scaled back. We're seeing a lot of technologies looking to do small package systems to make that more economical. but it is an expensive component of that. Some of the other options are you wouldn't be able to capture some of that LCFS value if you didn't upgrade the gas, but certainly beneficially reusing that biogas as process energy on site. You can also put an engine or a CHP system and generate electricity and heat that you could use on farm to reduce the need for grid electricity or natural gas or propane that is used on site as well. So there's several different options there.
Can the cattle waste still be used for compost purposes after going through the digesters, or is there anything left?
Kris, you wanna take that one?
Well, normally if we're going to do that, you're going to run it through a separator afterwards. And I mean, the amount of mass that's actually converted is relatively small. So I'll say looking at the stuff coming in versus going out is not going to be that much different. And so, and beyond that, I guess I'd say we need to do research to see what you're going to end up with, and see what you're going to do. If you want to haul it as a solid, you're probably going to have to separate it. Otherwise, it's a liquid manure that would be land applied, like swine manure.
Our office did sponsor some work to do a life cycle cost analysis of the Brian Sievers digester with beef cattle. And one thing we were looking at was what is his cost savings for fertilizer by using the digestate out of the anaerobic digester for fertilizer. And you know, it did come back that it is an asset. It is still available as a fertilizer, and the limited study we showed said, you know, that it was an effective and actually cost-saving approach.
There's kind of a follow-up to that, Shelly. If you start mixing beef cattle manure and dairy manure, will you be ineligible for Lcfs credits, or how much higher does your CI score get when you start mixing those manures?
Yeah, there's nothing that would make you ineligible. The issue with beef cattle manure is the regulation doesn't recognize that methane avoidance, that emission reduction, or that emissions ceasing. And so the CI score would be positive, you know, somewhere in the 20, 30, 40, positive 30 or 40 range. It'd be similar to a wastewater treatment plant digester. And that type of a carbon intensity score is not overly desirable in California because of the volume of these low CI projects. So you can still do it and you can still mix it. And then what would happen from a practical standpoint in the program would be you would have two CI scores. You'd have the CI for beef and you'd have the CI for dairy, and you would allocate the RNG production. And it's usually based on manure volumes and total solids content, but you would allocate the RNG production to each one of those. So definitely does not make you ineligible. It makes the project a little bit more complex, but the RIN perspective still remains the same. You would generate D3 RINs for 100% of that volume. And then you just have to do a little extra work to figure out how much came from how much came from dairy and how much came from the beef cattle manure.
Posing that same questions, but with a swine unit, is there a big difference there like there is with beef?
Yeah, the swine is set up the same way than dairy is. So usually you need more hogs. The hogs don't you know, produce near as much manure, an eighth, seventh, an eighth, a tenth of the manure volumes. But the same concept applies where if you're using lagoon-based treatment or deep pit storage, there is methane being generated from that process and being emitted. And you do get credits under the California program, under the Oregon program for a swine-based project as well. So slightly different mechanics of how you collect the manure and how you treat it. But from a process and from a program standpoint, those two are treated the same.
I'll just ask a question. in Iowa, we oftentimes refer to, or I'll say, dairy producers that have a earthen storage basin will refer to it as a lagoon.
Mhm.
However, it is not engineered and permitted as a lagoon with excess water to drive that material off. How does that affect it? If we just put the raw manure in, take it out, we don't add any water, try to do any processing.
I think that in that general setup there, Kris, I think that would still be considered a lagoon under the definition of the program, although you would need to analyze each one of these individually. There are some parameters when you estimate how much methane is currently being generated, emitted from these farms, is the deeper the lagoon, the better. Because if you have a big lagoon that maybe is 3 or 4 feet deep, you're not really getting those anaerobic those conditions without oxygen for the bacteria to convert that material to biogas and to methane. But in the deeper scenarios, if your lagoon is 8 feet deep or deeper, oftentimes these are 10, 12, 15 feet deep, then I think that would be, take a little bit more investigation, but I think that still under the Lcfs program would be the definition of a lagoon, because you still, from a practical purpose, that is generating and emitting methane.
Here's a question for Fred or Shelly. What is the potential for Iowa to attract the large 5,000 head dairies to Iowa, and then what are the challenges?
I can certainly say that would be a goal of my agency. Is it'd be great economic development to have more dairy industry in the state. So I do think that this more holistic approach to farming might help encourage that, as perhaps some projects have been limited by the handling of the manure. We've got some odor control benefits that definitely come, that people start to see these as providing economic development in a variety of ways, jobs, energy creation, in addition to bringing the dairy herds. I think that's certainly a good opportunity for the state.
And I'll contribute 2 things that I think as herds from out of our area consider. We recognize we've got feed, we recognize we've got water, but there's 2 things that always come up in that discussion. The first is, who's going to buy the product? When we look at South Dakota, they've put in a lot of processing. They're adding 20, 30,000 more cows because they have the ability to move that into a processor. The second thing that always comes up is the availability of labor. Are we going to substitute humans milking cows for robots? If we're looking to grow communities, having milkers is important. And when we're looking at less than 3% unemployment, they become a very scarce commodity. So I think as we look forward, what are we going to do with the milk, and who are we going to have in the communities as part of our work source are really important.
One other comment I'd say is you need about 1 acre of land for the manure application, and probably a little more than that for the feed stuff. So if you're looking at 5,000 head, that's about 8 square miles of farmland you're going to have to get. I'll just say it's going to be very, very hard to acquire that size block of land anywhere in Northwest Iowa.
So if a dairy is interested in exploring their potential, what are the next steps involved?
Yeah, I think assessing what's the herd size, what's the current manure management structure, and happy to talk through what that may look like. But just doing a quick, are all the conditions there set up for a successful project? And then if it passes that first check, then you do a little bit more investigation. You may contact the pipeline company to see where their pipeline is. Can they receive this RNG? Talking to some of the vendors to get a firm estimate on how much this costs. But yeah, that's all work that EcoEngineers can do and has done quite a bit across the country. I think that is the next step, is just opening up a discussion of what's going on at your farm. Does everything look like it's set up well? And if it is, then going in and doing some of that deeper dive and quantifying many of the things that we've all talked about here, and seeing on paper, does this look successful? And then if it does, you start engaging and figuring out what the project structure may look like. Who's going to own it? Who's going to operate it? Who's going to come in and do that? There's entities that will do that for you. Like I said, some of the farmers across the Midwest, across the country are taking that on themselves. There's a lot of opportunity and a lot of openness where when the farmer controls that manure, can determine how these things get set up and how best to put a potential RNG project together.
Along those lines, what is the investment community's general view of the LCFS market and the risk of it significantly dropping in value in the future?
Yeah, I think there's significant investment. When these projects really started in the early stages, maybe 5 or 6 years ago, investment was very timid. Rightfully so. There's not a lot of established, a precedent out there. But now with all of there's almost more money out there than there are projects because of the attractiveness and the returns. I think overall, obviously, it's still an incentive program, but that whole detailing out to 2030 in California specifically really helps bring that stability to the program. You can estimate and calculate how many credits will be needed in 2028, 2029, 2030, and that does provide some stability to the program. You do have some of that pricing uncertainty that the price may go up and down, but when you're doing that feasibility analysis, those are things you want to look at for your specific project of what's the break-even cost of doing this. Do you think that the market will get to below that break-even point? And the goal is to try to put measures in place to make that as least risky as possible. So we're seeing some forward hedges or selling some of the RNG at fixed prices and letting somebody else take some of that price risk. All of those are structures that are happening out there in the investment world. I think all of those are on the table, but as I mentioned, many of these projects have a 3 or 4 year payback period, and we can see somewhat well into the next 3 or 4 years, and we don't have to rely on super high credit prices in 2030 in California in order to make these projects successful. Capitalize on these high values now, and then there may be other markets that develop. Some of these other states may become more, better. Maybe Iowa does something in the future. Maybe Minnesota does something. And once you've got that investment paid off, you have the ability to move that RNG to these various markets and either reduce risk or capitalize on the next 5 or 10 years of the project. So there's a lot that goes into that analysis, but those are some of the things that investors are looking at. But we look at some of these large utility companies, like if you follow in the news, Dominion Energy in North Carolina, where there's a lot of hog manure, they're investing $1 billion in these projects. So they're going out there and partnering with farmers to do that. We see other utilities and other investment vehicles putting $500 million into these types of projects because they do check all of the environmental boxes. They check the returns, the economical boxes as well. And I think finding that right partner is a critical component to this, but that's not a huge hurdle in this current market.
Okay, this is kind of a two-part question. You had kind of mentioned it briefly in your presentation about who's buying in this area. So let's go ahead and kind of identify those folks. And then what's the status in Iowa? Are we going to create a program? Is it palatable in the state right now, or with the regime change?
Maybe I'll take the first part of that and Shelly can take the second component of developing in Iowa. We see a lot of activity in Iowa. We've worked on many projects in the feasibility or the development phase of looking at doing projects. I think Shelly touched on one that's is being implemented. I think there's a lot of activity. No projects that are operating from a manure-based project. None of those are currently operating in Iowa, although I suspect within 12 months that will change. We've seen a lot of Missouri. There's several projects, 6 or 7 projects in Missouri that are happening, and many in Wisconsin that are happening as well. So I think the table is set here in Iowa. It's still in the somewhat early stages of the implementation from having operating projects in Iowa.
So to further on that, I have been reading that nationally, some of the big player food processors, Cargill, for example, a lot of those have gathered together to form a consortium, and they're willing to pay more for renewable natural gas to power their facilities than they are for natural gas. I think that market will, will continue to increase as people are willing to pay more. As far as possible policy changes in Iowa, nothing's on the horizon right now, but Iowa has kind of a history of following federal policy. For instance, a solar tax credit came out about half a dozen years ago at the federal level, and Iowa mirrored that with a state level program. The same with the wind energy of 10 years ago. So it's certainly not out of the question. What our office has been working hard to do is to not just account for the energy value of RNG projects, but find a way to account for the water quality benefits, the soil health benefits. The other renewable energy resources don't offer that. And so it's a bit of a challenge to really quantify and give RNG that advantage from a policy standpoint. But I do think we're making progress. Scientists are helping us come up with better models and numbers, and I do think there's a good potential for policy changes in the future.
To piggyback on that, Shelly, I saw we had a question too of the credits. Are they tax credits? Who's paying for these credits? Is it taxpayers? It's not. So the programs are regulatorily driven. So the EPA administers the RFS, the California Air Resources Board administers the Lcfs, but it's really a mandate to the refiners and to the oil companies and people that purchase and dispense petroleum-based fuel. So it's not a tax credit. It's not something that it's a market-driven price for the credits, but the actual check, when you're selling these credits, it's to another regulated entity like a BP or a Shell or a Chevron. They're the ones that have to comply with this program, and it's nothing driven by tax dollars. The only thing that like federal taxes, they go to administer, the staff to administer the program, but the revenue of these projects comes from industry and refiners.
There's an interesting one here. Can a dairy farm supply RNG to an ethanol plant for process fuel and still get the extremely low CI value through the produced ethanol?
That's a second level question, and somebody's already picked up on this. So that's amazing. You've already got the CI aspect down. Yes, you can. Using that process energy instead of fossil natural gas can significantly lower the ethanol plant's CI score and make their ethanol more valuable in California. And I know, Shelly, maybe you want to talk. I mean, we've analyzed several of those. We've worked together on what that potential may look like, and maybe you want to pick up on that.
Yeah, one of the maps that I showed had the little dots where all the animal confinements were, and then the natural gas pipelines, but it also showed the ethanol plants. So we were kind of teeing up, I guess, an answer to that exact question. We think there is definitely some synergies between those industries. Unfortunately, ethanol has took a bit of a hit, as did everybody, I guess, with the pandemic we're under. They've been recovering well. If that trend continues, I do think that there may be some of those marriages between the biofuels industry and the on-farm RNG industry.
Question, Brad. You said that the gas is produced and then it's cleaned, and I believe there was some sulfur products taken out, and then it's pumped into the pipeline. What happens to those products? They sounded kind of nasty. How are they dealt with?
Yeah, that's a good question. That on that hydrogen sulfide, usually you're using like a sacrificial media that absorbs those nastiness, and then eventually that is landfilled. So there are some non-renewable components of this, but all of that goes into that carbon intensity score. Most of it is just carbon dioxide that's removed. That's about 40% of the total volume of biogas is just CO2, and that's usually destroyed through a thermal oxidizer. And so you do have to kind of break that and destroy that, and it's usually vented into the atmosphere after it's destroyed.
So what are the risks for producers in these kinds of projects?
Yeah, I think it depends on what the structure, that producer is looking for. Obviously, if they want to do the project themselves, they have capital risk. They have some market, some regulatory risks. I think our job when we're helping people through this is to let them know what those risks are, and then how do you mitigate those as best as possible. So you have obviously that. I think the markets are very attractive right now, and the goal that we always preach is use those higher value markets to get the project and get that capital paid off. Once the capital's paid off, at the absolute worst case, you just stop, you shut the system down and you stop doing that, or you use the biogas internally as process energy, and you get a small benefit from that. So a lot of the risk is on the capital front. If you partner with a developing partner, then they're taking on that capital risk. And really the risk you have is it a good working relationship with that developer? You're sending them the manure, like kind of Kris said, that the project is extracting the energy, and then you're getting the nutrients back and doing what you've done before. So there's a lot less risk if outside of capital. There's not that much risk to the farmer. Obviously, you still need a good partner. You need that good development partner that knows what they're doing, and that's a key component to a successful project here. Operationally, obviously somebody needs to operate this, whether that's and it is specialized equipment. There's people out there, there's companies out there that can do that. I know I think Shelly could probably talk about, the goal of within the state is to create entities that will operate these facilities, so that have that technical expertise to do so. Right now, it's usually relying on a developer partner that has experience operating these. So there is a little bit of operational risk as well.
Yeah, on that operational side, wastewater treatment plants is where you would turn to find people who have this skill set. And there are good training programs in the state to train wastewater treatment operators. But we are certainly thinking of, as this AD technology hopefully takes off in the state, is how to have the workforce to keep up with the successful operation of the units.
Lindsay, I know we've got some questions left, but I want to remind folks that the program has been recorded and it will be available if they just Google Iowa State Extension Dairy Team, pop up to our website, click on webinars, it'll be there. And then if they are listening to it from the archive or at the end today, if they would please participate in the survey, that helps us have better programs in the future. Lindsay, didn't mean to interrupt your questions, but I wanted to get that in.
I'm going to put the survey in the chat. They've been disappearing, so I'm not sure if everybody can see all these survey links, but I'm going to put it in there one more time in case anybody needs the link for that. What do we have here?
While she's looking, Kris, question here. Does this affect our water quality? Will it put more management to have clean water in our streams, or will it, bottom line, help put clean water in streams?
I mean, properly land applying the manure at the end of the day, so that you're putting on what the crop is taking off, and doing that, I'll say that's the essential part. If this makes that easier, that's going to be better. If it makes it, I mean, if we're able to haul the manure to a greater distance where we have land that's deficient, that will certainly make it better. I don't know that I'd say that's going to be a tipping point or not. I'd say that's more of a neutral thing. You've got good skills at properly applying it, they'll stay the same.
So I know this is a dairy discussions manure conversation, but here's a question here about can manure digesters accept outside feedstock that isn't manure? And if so, how do they go about doing that? Can it supplement? How does that work?
Yeah, they definitely can. I mean, really anything organic that can come in to the digester can be converted. When you start mixing a bunch of feedstocks, then you start getting operationally, there may be more complexities and more challenges. The microorganisms that actually do the work, that consume the organics and generate biogas, they like a very consistent and steady diet. And so it's not as simple as saying if a load of something comes up, you don't just dump it in the digester like you would with a landfill. You really have to monitor and slowly feed in that material because the bacteria they'll eat too much, they'll eat too little. They really want that same recipe day in and day out. But it's definitely a possibility. It just takes a little bit more analysis and management of the process.
And I think there might be cases where mixing some other feedstocks could boost your gas production. I know we've worked with EcoEngineers to do some analysis looking at corn stover and also cover crops as ingredients into the digester to be mixed with manure. You know, we do think this might be a way to provide a market for cover crops and encourage more people to plant those if they have some value as a feedstock into a digester. And, you know, and that's another way to get to some of the other environmental benefits that you can tie into digester projects.
I think that's really the next level. You know, once you get this base project set up, the next level is then how do you optimize all of these components of a project? I think that can be traced all the way back to, you know, if you're growing cover crops or maybe farm practices, how can you optimize farm practices? And yes, that may mean more work for the farmer, but that should mean maybe there's revenue on the back end that can be shared in order to do that. And so once these systems are set up, then in operating, you're going to that next level and analyzing where can you enhance the project throughout all of these processes, and what are the markets you can take advantage of, what are the revenues available, and how can those be shared across all of the parties to return value to the farmer, to the investor, to the developer, and to make all parties kind of happy in the relationship.
I know we talked a little bit about potentially, you know, building a connector to a pipeline, but there aren't currently many farms not located near a natural gas pipeline. So can we discuss the viability and current cost of RNG compression, hauling, and injection? And then how does this approach, or a hub and spoke approach, have impact on RINs and Lcfs credits?
Sure. Yeah, I think it certainly is an option. We've seen, I don't know if I have a figure, but you know, 20%, 25% of the projects out there are more remote, that they are compressing that gas, loading it onto a truck, and then driving that truck to an injection point. And I know there's a couple of utilities in this general area that are looking at that hub and spoke model where they can receive RNG from a variety of sources. That doesn't really, it makes the compliance a little bit more complex when you do this, but there's nothing that setup would not disqualify anyone. Actually, it's happening quite a bit throughout the industry, but it does add some complexities.
You would also have the opportunity to probably go through one of the solid separators, all the solids to the site, and be able to extract the energy that way. I mean, not saying you can go a long ways, but you can probably double or triple what you would go if you were hauling them.
There's a question here about a recent Washington Post article saying that feeding cows seaweed might decrease the amount of methane they excrete. And is there any substance to that? And could that be a potential headwind for the anaerobic digester industry? Is it related?
I think from a manure standpoint, I mean, the cows, the methane that you're getting credit for capturing comes from the lagoon side, the manure management practices, and not what's coming out of the cow itself. But so I think as long as the cows, you know, produce manure, there's still the opportunity to do this. I'm not familiar with the article and what that may do. I know a lot of people are looking at ways to, you know, dairy emissions or beef cattle and dairy emissions are one of the, you know, from a food processing standpoint, are high in CO2 emissions. And so I know a lot of people are looking at doing some other things. I think the concepts that we're talking about here today, while somewhat new, the digester technology, I think Shelly mentioned, that's been around for, you know, decades and decades. The upgrading system has been around. So I think the easiest solution is doing more of these projects and getting that built out, And then, like I mentioned before, you can start to optimize all of the other components of this project to reduce emissions. But I haven't seen the article, but it's an interesting concept.
We talked about IEDA a little bit, but is there any other way that the state or IEDA can help get these projects started, or any places producers can turn?
Yeah, I mentioned that we've got a guide coming out in 2021. Hopefully that'll be a good place to get people, you know, a lot of the concepts that we talked about today can be presented and help people understand how to get connected to the people who can make projects happen. So that'll be coming out. I mentioned briefly that there was the bonding authority that the Iowa Finance Authority has that could potentially come into play for some projects. But, you know, other than that, we've largely been trying to connect the dots, bring all the stakeholders together in the state. You know, and I really think that's been happening the last couple of years. I want to make sure people are aware of a group out of Iowa State University that goes by the name Sea Change, capital C, and then the word change. You know, they're very instrumental as we you know, try to do the research and get the science that we need to alleviate any of the concerns that have been brought up around the AD industry. And then I'm looking forward to see what the Carbon Sequestration Task Force has to say and what recommendations they have for the government. So that will, you know, definitely, I think, chart our course in the coming year.
Awesome.
Just to kind of go reference back to the seaweed, I had to check what the Post referenced, and it's California data that does show a significant change if cows consume a certain portion of the seaweed. Also has some production influences. So new research, very exciting. We'll have to go a couple years down the road before we figure out what it really means.
I have a question here. I think I know the answer, but is there an easy way to calculate the CI of a farm? I would say not an easy one, but
yeah, just call Brad.
Yeah, there you go. It's interesting. That's you can go and if you Google, it's a GREET model, GREET. California puts the models out on their website for free. But if you open it up, you're going to see a big spreadsheet with a lot of inputs that don't make a lot of sense. So usually what happens is we'll, you know, at initial level, we can get a general idea for where the CI score may be. And then it really does take modeling in order to firm that up to see what that revenue potential is. So anyone can take on that ability. I'm in the industry and we do this all the time, and we have a dedicated team that's all they do is model these facilities, and it's pretty intense.
Looks like we've got a couple more minutes left. Have you still got some questions we need to just can't live without hearing?
I have a couple timeline questions. Like, what does it even take? How long does it take for a project like this from the beginning to when it starts producing? And then how fast, or once the gas is produced, how long does it take for certification for RINs and LCFS credits?
Yeah, I think in general, it takes, you know, to put all to do the analysis, to put everything together, you know, just throwing numbers at 6 months maybe to get all of that together. maybe another, depending on the project size, another 8 to 12 months to build it, and then another few months, several months to get all of the certifications. So, you know, usually around 18 months to 24 months to get all of this done and generating revenue, although that can slide forward or backwards depending on complexities and a lot of other factors, but somewhere in that ballpark.
Initially, that tap the pipeline was a little bit of an unpredictable piece of a timeline, but it's actually happened a couple times now in the state. And, you know, I think maybe we've gotten over that hurdle of the burden of proof to ensure that that's done within the proper regulatory and aspects. So, you know, I think that the timeline of future projects is going to be a little bit less than the ones that have happened the last couple of years.
Well, we'd like to thank everybody for being part of the program today and for the questions. Remind them that the program will be available at the Iowa State Extension Dairy Team website. And please spend a few minutes answering questions from the survey. Thank you to the team from EcoEngineers and to Dr. Kohl for helping us put the program on today. Any final thoughts from the presenters?
Just thanks for your time. Happy to answer any questions that that you have. Just reach out, and you know, we'll be happy to work with you.
Very good. Lindsay, thank you for being part of the program. Enjoyed co-hosting with you. We will be looking at the next program a year from now, as our Dairy Discussions is an annual program. So thank you all for attending. Good day.